Okay, we stopped here last time, and we were talking about the bouncy force. We stop here in a core bouncy force. In case of the core, little bit situation is different because you can see that this is a core, right? This is a core. Core being made of sand also, as you know, as I explained to you previously. So core made of sand. Usually core, we put the core inside the mold. We put the core inside the mold, as you can see here, and core being used to create the internal cavity. This is the internal cavity. So liquid, when we fill the liquid or when we pouring liquid, liquid will fill all cavity around the core, and the liquid will be surrounding core from everywhere. This is the liquid, and then while solidification, when this part will solidify, the core will be still remaining inside and made of sand. Later, you remove the sand from inside, then you can find core creating a hole in the or cavity in the or hole in the main part or the cast part. This is the functionality of the core. As I told you before, core is complicated. Core is complicated. If you can avoid having core in a mold, it will be better. If you can avoid having core in a mold, will be better because you see that it's really complicated. But in some cases, it is essential to have a core inside because core usually is, if the dimension is very big, if you don't have core, then you have to do machining, have to cut this one and this big waste of material. Then in this case, core is essential. You must consider core inside. So in case, then you have to consider the core in the mold. So core, as you can see, is surrounding by liquid from all sides. As you can see here, core is inside. When you put the liquid, it will be surrounded by liquid from every side. Initially, when core here, there are the weight of the core. When you put the core here, the core no liquid yet. At the beginning, before you put the liquid, when you put the core will be under its own weight. Then the weight of the core equal to mg. Weight of the core equal to mg, mass multiplied by gravity acceleration. And the mass of the core equal to rho g. Then rho v قصدي, sorry. Then rho vg. Then weight of the core equal to rho vg. Rho is sand, definitely. This is the density of the sand because core made of sand. So rho, you can see that rho of sand. So rho sand multiplied by v core, volume of the core, rho v, which is the mass, multiplied by the gravity acceleration. This is initially before you put any liquid inside. But later when you put the liquid, then what will have? Then now we have the weight of the core. Let me just highlight here. This is the weight of the core. Weight of the core like this. This is the weight of the core. Initially, weight of the core affecting in this way. This is the weight of the core. Let me put it here. Weight of the core. So weight of the core, this initially weight of the core before we put the liquid, then no liquid yet. When you put the core inside, it will affect it, or the weight of the core affect the situation. If you leave as it is, then this one will collapse, will not be able to withstand the weight here. Then we must put initially, before you put the liquid, you must put here this kind of whatever we call it, chaplet. This is a chaplet. This is a chaplet. We must put chaplet below. We must put here chaplet below. This is chaplet actually very important. Why chaplet is very important? To support the core initially. Now no liquid yet. Then you need to put chaplet here to support the core initially, to not collapse. If you don't put the chaplet, then the core will collapse, will not be able to withstand the condition. So initially weight of the core. So this is the weight of the core, right? And you put chaplet here. This is the chaplet here. This is the chaplet here. Later you put the liquid. The liquid will fill everywhere. Then someone will say that you put chaplet and you put liquid. This chaplet will be part of the liquid. Actually, chaplet will be almost same material of the liquid. Same material of liquid metal. Then liquid metal is very hot. When you put the liquid metal, chaplet initially support, later will be part of the metal, and later when solidify, all part will solidify together. This extra part you can cut later by machining. Then this one will consider be as a part of metal. It is kind of a little defect, but unavoidable. We must have unavoidable. We cannot just simply remove it. We have to have chaplet in a casting to support the core. Otherwise, if you don't put chaplet, due to the weight of the core, this one will collapse. That's the first. Second, when you put the liquid here, then you can see that this is the weight of the core. This is the weight of the core. Can you see that? This is the weight of the core. Later, when you put the liquid, liquid will fill everywhere. Then liquid will push the core up. Then liquid here, when you put the liquid will come and will push core up. Then you get another force later when you put the liquid, which is liquid force. Then liquid force is like this. So initially weight of the core, later the bouncy force. Let me write bouncy force. Then you have two forces, weight of the core, and then you have liquid force. Liquid force is up. Liquid force pushing this one up. When you put the liquid will come, stay here and pushing this one up with force. Then the weight of, we call it, is the weight of the displacement fluid. Displacement fluid, what is a displacement fluid? Actually, this is the force that pushing the core up, which is the weight of displacement fluid. Displaced fluid means the weight, suppose initially if no core, liquid will fill everywhere, but because the core is here, some liquid here will not be filled because of the core is remaining inside. So this the volume the weight of displaced، يعني السائل المزاح، وزن السائل المزاح. يعني what's the meaning of displaced fluid? Mean it is removed. The weight of the liquid removed from this place, which you removed because of the core is remaining inside. So weight of the displaced fluid is a force, that liquid force that applied here, the core, applied on the core, which is equal to M multiplied by the M of liquid, the mass of the displaced fluid multiplied by the gravity acceleration. And the mass of the displaced fluid equal to rho m liquid, rho m meaning rho of liquid or rho of liquid metal, which is liquid metal, density of liquid metal, here rho m, which is the density of liquid metal, multiplied by V of the core. Why V of the core? Because the liquid, displaced liquid, the volume of displaced liquid is exactly equal to the volume of the core. The volume of displaced liquid or السائل، حجم السائل المزاح exactly equal to the core volume. So rho metal, because this is the displaced fluid, rho metal multiplied by V core, which is the mass, multiplied by gravity acceleration. Then you have two forces, one up and one down. Then here one up, the remaining force here, the remaining force is the difference between Wm and Wc, Wm and Wc. This is a force up, this is a force down. So the bouncy force remaining is a balance between Wm minus Wc. Wm, which is this one bigger, this is based on Archimedes law. This is the Wm based on Archimedes law, minus Wc, weight of the core. Then it gets that G and Vc are common. G and Vc, let me just highlight, G multiplied by Vc, and also here you can see that it is G multiplied by Vc are common. These are common. Then G multiplied by Vc are common, multiplied by rho m minus rho s. Rho m minus rho s. When you look to this one, you can see that this is the balance. This is the difference between the weight of the core and the liquid force. And this force actually, the difference between Wm and Wc, this force actually acting upward, pushing up. then you need to add another chaplet here. Why you added another chaplet here? Because when you put the liquid start pushing this one up with the difference between Wm minus Wc, which is considered as a bouncy force. And as long as we have bouncy force pushing up, if you don't put chaplet to support here, if you didn't put chaplet to support here, this one will collapse also. Then you need to add a chaplet up. So you need to add a chaplet up and chaplet down. So this one to support initially the weight of the core, this one to support the bouncy force later when you put the liquid in the mold. Right. Yes, Abdurrahman. Yes, I'm listening. Any question? No question? Okay. So let's take an example.
Doctor,
Yes.
you mean me, Mubarak?
I don't know who would like to ask. Someone would like to ask. Yes.
Yeah, me.
Mubarak, yes.
I have a question about weight of the. Can you, for this slide, weight of the displacement fluid. Since it's weight, why we consider it up, not down? We usually consider the weight direction downward, not up.
Exactly. But this is liquid fluid. They consider liquid fluid pushing up with the equal force as the weight of displaced fluid, because this fluid supposed to be filling this area. This liquid supposed to be filling this area, but because of the core is here, then this liquid displaced around. Then this liquid pushing up. This is based on Archimedes principle. Then this liquid pushing up with the force equal to the weight of displaced fluid. Because displaced fluid is supposed to be here, it is not here. This is the reason why if you go to the swimming pool and when you just get in the water, you feel that water pushing you up, not down. Because this is not your weight is down. When you look to the swimming pool, when you go there, لو انت رحت حمام سباحة ونزلت في المية وزنك لتحت، مظبوط؟ وزنك لأسفل، لكن المية بتدفعك لأعلى مش لأسفل. الفورس بتاعت الليكويد هنا equal to the weight of displaced liquid، يعني حجمك مضروب في كثافة المية. دي equivalent force. Did you get it?
Yeah, I get it.
This is based on Archimedes principle. ودي الفاندامنتال اللي being used to manufacturing submarine والchip and so on. يعني دي الفاندامنتال اللي بتستخدم في تصنيع السفن والغواصات هكذا. يبقى هي القاعدة liquid fluid pushing this one up equivalent to the weight of displaced fluid supposed to be here, which is equal to الماس بتاعت الليكويد اللي هو كان المفروض يملى multiply by gravity acceleration. That's it. Did you get it?
Yeah, it's clear.
Let's take an example and see how to apply this fundamental or rules in an example. Chaplets are used to support a sand core inside a sand mold cavity. Chaplet. This one is a chaplet. We call it chaplet. Chaplet being used to support the core here, as you can see here, in sand mold cavity. The design of the chaplet and manner in which they placed in the mold cavity surface allow each chaplet to sustain a force of 10 pounds. Then each chaplet can withstand 10 pounds. Only 10 pounds. So each chaplet can only sustain 10 pounds, no more, right? Several chaplets are located beneath the core to support it before pouring, and several other chaplets are placed above the core to resist the bouncy force during pouring. يعني ايه الكلام ده؟ بيقول لك several chaplets يعني not one but several chaplets are located beneath the core. Beneath the core يعني below the core. Beneath the core here to support it before pouring. عشان to support it before pouring, before we put the liquid. This is the one. So several, not only one, several we put here to support this one initially before we put the liquid, and several other chaplets here are placed above the core, to resist the bouncy force, This is what is given. If the core volume here, this is a core volume given 325 cubic inch. This is the core volume, and the metal board is brass. الليكويد اللي احنا هنحطه هنا is brass. Weight density of the brass 0.313. He give me weight density. Weight density mean rho G. Rho G equal to 0.313 determines the minimum number of a chaplet that could place. Determines the minimum chaplet. The question is, determines the minimum chaplet could place or that should be placed below and above. Below the core, and weight density of the sand is given also. So weight density of the sand, let me highlight. This is the weight density of the sand. This is the weight density of the brass. This is the volume of the core. That what are given. So volume of the core, weight density of the brass, weight density of the sand. We need to know how many chaplets we put below, how many chaplets we put above. This is the question. Okay. When you come to here below, there are no liquid yet. When you come to below, there are no liquid yet. Then the weight of the core, we need to calculate the weight of the core. Weight of the core equal to rho GV. Rho is the sand. Rho of the sand. Here, you can see that. This is the rho of the sand. Multiplied by the volume of the core. Rho of the sand multiplied by G multiplied by volume of the core. Rho G of the sand we know is given. Weight density of the sand given. Then this is the weight density, and the volume of the core also given. Then you can obtain weight of the core. This is the weight of the core, 18.85 pound. 18.85 pound. Then this is the weight of the core. We need to put chaplet to support the weight of the core. However, one chaplet can support only 10 pound. Only one chaplet support 10 pound. You will ask me, one chaplet support 10 pound. Why is this made of metal? Yeah, because it is not because of bolt or chaplet, but because of sand. If you support more than 10 pound, it is penetrate and just move down. So we don't want this one to penetrate and move down. So maximum 10 pound. We don't want to load chaplet more than 10 pound to not beneath or to not penetrate in the sand. So maximum 10 pounds. In here we can see that the weight of the core is almost 20 pounds, 18.85. So how many chaplet we can put below? We can put at least 2. Then we can at least put 2 chaplet below to support the core in case of no liquid yet. He said that probably we can increase to 3 or 4 to be sure that chaplet will perfectly support the core. So probably we need to put not only one, but more than one. Not only 2, but more than 2. This is the one. This is the first question. How many chaplet to put below the core? This is the question. Second, how many chaplet to put up here to support the core later when you put the liquid? Then we need to obtain the weight of displaced fluid. Weight of the displaced fluid is the raw metal. Raw metal, be careful. This is raw sand, this is raw metal. This is raw metal multiplied by G multiplied by V of the core, also V of the core. Rho G is given, which is the weight density of the brass. Rho G is given with the weight density of the brass, so Rho G given, and volume of the core we know, then you can obtain then weight of the displaced fluid. This is the weight of the displaced fluid pushing up and core pushing down. The balance or the difference between both, which is a bouncy force. Bouncy force equal to weight of the core minus weight of the liquid, or the liquid force minus the core weight. Then you get 82.88 pound. 82.88 pound up. Then the force after you put the liquid, you have upward force equal to 82.88. So how many chaplet you put? Every chaplet need 10 or can support only 10. Then you need 9, at least 9. At least 9. You cannot say 8, because if 8 you support more than 10. So at least 9 chaplet required above. This is the number of chaplet required below and number of chaplet required above to support the core before you put the liquid and after you put the liquid. Any question? Any question? Clear? Next is if I ask you here, you can see that there are a core here. This is what we were discussing about when you put the liquid, you put chaplet below and chaplet up to support the core before and after you put the liquid in the cavity, right? Perfect. So this is the one. But here, if I ask you here, this is the core, right? Please give me your attention. This is the core, right? What is the bouncy force in this core? What is the bouncy force here? Can you realize the bouncy force here? What is the bouncy force here? Actually, zero. The bouncy force here in this case is zero. Why? Why bouncy force here is zero? Because bouncy force always just pushing from below to up. When you put the liquid will come, fill here, and then applying force as a bouncy force. But here there are no liquid below. Yes, there are a liquid around, but no liquid below. Then bouncy force meaning push from up to down, from down to up. There are no liquid below the core to push. Then bouncy force in this case equal to zero. To have bouncy force, you must have liquid below the part. Then you get the bouncy force. Otherwise, if no liquid below, then no bouncy force applied in this case. Right? Any question? Okay, this is the end of yes, Muhammad.
دكتور، الحين هذا الشكل حق الكور اللي تحت كيف يصير الشكل؟ يعني أنا اللي عارفه أن الكور مثلا يسوي الفتحة اللي داخل، صح؟
نعم مظبوط، كلامك صح.
ايوه. طيب الحين دام انه مقفل على ما يمدي يجي عليه السائل من فوق ومن تحته، فشلون يصير؟
مش مقفل. اسمع بس، مش مقفل، هو اراوند. الديامتر بتاع الكور اصغر من الديامتر بتاع الهول اللي هنا، فالليكويد بيلف من حواليه. انت بتحط الليكويد هنا، الليكويد بيخش هنا، تمام؟ محمد سامعني؟ الليكويد بيخش هنا، مظبوط؟ الديامتر بتاع الكور ده اصغر صحيح. من الديامتر بتاع التجويف، فالتجويف الليكويد بيلف من حواليه، اب وداون مفيش، لكن بيلف من حواليه. دي جت. وشكل شكل البارت هيبقى اسطواني، شكل البارت عندنا هيبقى اسطواني، من جوه فاضي والليكويد من حواليه، الليكويد بيلف من حواليه. دي جت. You understand?
Yes. Thank you.
That's it. Yes. You're welcome. Any question, guys? Any question? Okay, if no question means this is the end of chapter 7. This is the end of chapter 7, and now we're going to move to chapter 8. Chapter 8, which is casting processes. Now chapter 7 was the fundamental of casting. Chapter 8, casting processes. Okay, so chapter 8, we're going to discuss all chapter 8, all our metal casting processes. We're going to cover in this chapter sand casting, other expandable mold casting, permanent mold casting, foundry practices, casting quality, metal for casting, product design consideration. This is the item that we're going to cover in chapter 8. This is the item that we're going to cover in chapter 8. I'd like to remind you, in a casting, we have two types of the casting: expandable mold casting and permanent mold casting. Expandable mold casting, where we're using the mold for only one time. We manufacturing the mold and we use the mold only for one time. We destroy the mold and take part out. Permanent mold processes that we use a mold for several times. We made this mold maybe made of metal, like made of steel or cast iron, or maybe ceramic, or maybe refractory material or something, and we use for several times. We use to cast several parts, right? This is a big difference between expandable mold processes and permanent mold process, right? The big advantage of expandable, I remind you, this one we discussed previously in chapter 7, but I remind you again. Then the big advantages of the expandable mold, the big advantage of expandable mold is complex shape. Expandable mold can create a complex shape over permanent mold. Permanent mold difficult to create complex shape, but expandable can. Why? Because in expandable mold you made of material that you destroy and take the part out. It doesn't matter how complex it is. If it is very complex, no problem at all. You can just destroy the mold and take part easily, right? But in a permanent mold, we would like to maintain the mold. We would like to keep the mold. We're going to use for several times. We're not going to destroy the mold or sacrifice the mold. Then, in this case, less geometrical complication can be done in a permanent mold, or less complexity could be done in a permanent mold. This is the big advantages of the expandable mold over permanent mold. However, disadvantage of expandable mold, that production rate is limited. Why limited? Limited because the time needed to make the mold is big. It is high. You have to consume more time to manufacturing the mold. So it is limited by the time to make the mold rather than cast. Cast itself not taking time, but time to make the mold is taking longer time, and then production rate is getting smaller. This is a disadvantage. Permanent mold is opposite. Advantage is a higher production rate. Why higher production rate? Because you manufacturing mold for only one time and use for several time for mass production. Then you reduce the cast time here will be short compared with the time in expandable mold. This one being used in a higher production rate, but disadvantages in permanent mold, that geometry is limited compared with the expandable mold process. This is a big difference between the expandable mold and the permanent mold. Overview of sand casting. We start with the expandable mold. In the last chapter, in chapter 7, we discussed about the sand casting, and this is overview of sand casting. I remind you what we had, what we discussed previously in chapter 7 about the sand casting. This is a mold in sand casting. This is a cup, this is a drag, this is a bison, pouring bison, this is a Spiro, this is a gate, well, runner, blind riser, main cavity, and you can see that the cavity is rotating around. Muhammad, cavity here, you can see that it is rotating around the core. This is the core inside, this is the open riser, and this is the vent. This is the parting line, and this is a flux. This is what we were discussing in last chapter, in chapter 7. This is sand casting. Let me just quickly discuss overview about the sand casting. This is the part being produced by sand casting. Big part can, small part can. Many material usually casted by sand casting. It is really dominating in a casting process. However, the production rate, you have to consider that the production rate is less compared with the permanent cast mold. This is a steps in sand casting. Sand casting here, as you can see, we create the mold, we create the cavity, we prepare liquid and melt liquid, the metal melt the raw material, and then we pouring liquid inside and then leave for solidification. While solidification, then part will be ready. You take the part, you destroy the mold, you take the part out, and then probably you need to do cleaning, maybe machining, maybe heat treatment or whatever process. This is a quickly revision about this one to refresh your information. Sand casting here, this is a several steps to manufacturing or to make sand casting. Finally, this is a product. This is a pattern. You have to prepare the pattern, and then you cut pattern twice, and then you do plate assembly, and then you added whatever is a runner, a Spiro, riser, whatever details you added, and then you create a cavity up and down in a mold. You do a mold assembly and core assembly. You added chaplet, probably you added the liquid, then finally gets apart. This is detail of sand casting as we describe. And sand casting made of sand together mixed with a binder material. We call it as a green sand, and we call it as a green sand because of the moisture inside. So it is a sand combined or mixed with clay as a binder, maybe synthetic material, maybe natural material, some chemical additive, and then this one will be ready and be used in the molding. Let me show you something. Yes.
Sand mold casting, also called sand casting, is the most common casting process. It is applicable to a great variety of metals, and there.
Right. So this is a sand casting. This is a sand casting. Let me show you this nice video to describe or to show you about the sand casting. Do you see the video? So here, this is the pouring liquid. This is the opening actually. This is the opening. Then we see that when you put the liquid again one more time quickly, when you put the liquid, this is a sparrow, this is the open riser. You can see that there are many open risers. It depends on the size and so on. The liquid will move out from here. We can understand that all area is, this is the cavity. This is cavity. This is the cavity. This is the many part being produced by casting. Actually, this is the casting production. You need to clean, you need to do sometimes. This is the cast part. This is the mold. Then now they destroy the mold and it. Now this is a mold preparation. This is a flask. This is a mold preparation. This is a flask. This is the sand inside. And now flask is removed. This is a cup and this is a drag. This is a cup and this is a drag. This is a sparrow. This is a riser. This is a pattern. They put the pattern here. This is here you can see that this is a bison cup, this is a sparrow, this is a runner, this is the gate, this is the main cavity, this is the main cavity, and so on, details as we described. Now they put inside everything, so all detail is created inside by using the pattern. Actually they assemble the pattern first and then you put this one to create the cavity, then later they take pattern out and then keep only the cavity. This is now creating cavity, and later when they remove, then you put the liquid. When you put, this is a sparrow, this is the liquid. You put the liquid metal. It is aluminum liquid. They put liquid metal here. This is the open riser actually. Can you see that this is the open, many open riser. It depends on the shape. Actually, they feeding for, because the part is big, then they feeding, there are two sparrow, not only one sparrow, but two sparrow. They feeding from here and here. The liquid come up here. When liquid come up here, we can understand that all cavity inside totally fell. Now they destroying the mold. It is made of sand. As you can see that it is brown or black in color. It is not green. They call it green sand, but actually color is not green at all. Then now manually feeding, as you can see here, manually feeding several casts here. Several casts. So time being consumed here. This is green sand mold. No pack mold. As we describe also, there are no pack and shell mold. So this is the item. So green sand mold, as you can see, this is the mold being made. This is the automatic feeding by using robotic arms. This is a robotic arm, and now robotic arm feeding at constant Q. This is a flow rate, usually is constant here. This is a part being made of casting. This is the car engine actually. The manufacturing car engine by casting. This is a part being made by casting. This is a product made of aluminium, as you can see, or aluminium alloys. So several parts being produced and so on. Okay, I'll stop here. Okay, so get back again to the slides. So this is what we calling is a sand casting. That's what we discussed here about the sand casting. This is the way how they dealing with sand casting. Okay, let me just a second. Right. Other expandable mold casting process. Other expandable mold casting process. Other different from sand, but still expandable mold. So other expandable mold casting. So it is different from sand, but still expandable mold. What is the expandable? Expandable mold, we destroy the mold and takes a part out. So other expandable mold casting. Why other expandable mold casting? Why we have to do other? Actually, this is the people trying to improve. It's kind of improvement. We try to do improvement in a sand casting. Try to do improvement in sand casting, or try to try to find another ways to do a better casting process or high quality process compared with the the one we had in a sand casting. Even sand casting dominating the casting process, but this is a kind of trial to improve. We have whatever we call is a shell mold casting. Shell mold casting is we creating or we using shell. We using shell to do the molding process. This is a shell actually. Shell is a pattern. We made a pattern exactly as a negative of the needed part, and this is one made of metal. This is a box. We put the sand in a box, and this is the shell, and then you heat it. You heat it up to a certain temperature, and this is a sand, green sand, ordinary green sand. And then when you this inverted it, you invert the box. When you invert the box, the sand will drop and cover all the shell. And later you invert it again, and then you find a layer of sand will stick with the heated pattern or shell, creating a layer here. You take this layer and put in a furnace to dry it. When you dry it, you remove all the moisture and make it the hard skin and make it solid. Then you take this one together, I mean the shell and the sand, you put in the furnace until this one layer becomes solid. Then you take this layer out, which is a shell, and assemble in a box here and put sand, ordinary green sand. Then you bring shell, this is two shell, this is two shell here, you bring two shell, one shell and one shell, and you cover here with the sand, ordinary green sand, and then you put the liquid inside, you finally destroy this mold and it gets apart. Let me show you another video to make this one clear. Can you see the video? Right. This is the shell. This is the shell. Heated. We heat it. This is the sand. Then we invert it to totally cover, and then invert. After a while, invert again. Then you get this one covered with this one. You put in a furnace, and then when it becomes dry, you bring a box and put here, assemble and put sand. This is ordinary sand. Then you put liquid in the shell. Then you open this one, finish. Then you take this one, you destroy. Then you obtain the part made of, as you can see. So this is okay. Okay, just give me a second. Get back again to the slides. So this is a shell mold. This is the shell mold. Again, shell mold. You're heating the pattern or shell, and then you invert it. Then this one will totally cover. Then you leave it for a while, and then invert it again. Then a layer will be stick with the pattern. You take this one and put in a furnace, both together. Put in a furnace. When the shell become hard, then you take the shell out and you do assembly here, and you cover here. You put sand here, and then you put liquid inside. Liquid will fill this one. Later you destroy, you take part out. This is a shell mold. Right, when you have the shell mold, this is the shell is kind of actual one shell. This is shell being made. This is a part being produced actually. This is a part being produced made of metal. This is a shell being used to create this part. So this shell is created as we described in by using the metal pattern. This shell is created, then you assemble, you put in a box, assemble this too, and then you cover with the sand, green sand to support. You put liquid inside. This is a part, then you destroy later, you take this part out. It's like here, this is a shell, then you create here, you put liquid inside, liquid will fill all the cavity, you destroy the mold, you take part out. Actually, this is a product being used by using shell. This is a shell mold cast. This is the shell mold cast. So when you look to the shell mold cast, you can see that to preparation, it is a heated, the pattern heated up to 175 to 370. Actually, we heating the pattern. This is the one coated with the silica. We coating the pattern with the silica easily. We can just remove this kind of shell. We heating this one in a furnace, clamp to the box, and box contain the box. We added supporting actually. This is a binder. Sand mixture plow over the pattern and then filling shell and give light and send mold. Then you can take part out. This one produced something like smooth mold wall, low resistance. Mean the mold wall. This is a mold wall. Mold wall is inside. I mean, this kind of wall is very smooth and low resistance compared with the sand mold. Quality is higher. No moisture and no kind of defect happen due to the moisture, gases, and bubble. Sharp corner can be reduced and small projection can be happen. Actually, this leading us to show this is the many parts or many product can be produced by what we call is a shield mold. And this is always people try to improve. This shield mold is a kind of one trial. It's being used actually in industry. You can find shield mold in industry. Advantages is smooth cavity. Surface permit easier flow of molten metal. This is why it's of improvement. Good dimension accuracy compared with the sand casting. Machining often not required. In many cases, machining not required. But if you have higher accuracy, probably machining could be used. Mold collapsibility usually avoid cracks in a casting because there are no moisture and cracks. And the cavity is less can be automated for mass production. This is another issue. This process, a main advantages here, can be automated, as you can see, can be automated for mass production easily because the pattern time creating mold is easy. Creating a mold here is easy compared with the sand casting. In sand casting, it isn't somehow difficult, but here creating mold is easy, can be automated for mass production. The disadvantages is expensive because they need some equipment and this equipment costing some money compared with the case of sand castings. It is more expensive, difficult to justify for a small quantity, usually being used for higher production. This is another method, not ordinary sand casting, but we call it shell mold casting. Next is another process. This one really important. We call it is expandable polystyrene casting or lost foam casting. Lost foam or expandable polystyrene casting or lost foam casting. When I said lost foam, meaning that, do you know the foam? The foam is white in color, being used in protecting electronic devices. When you go to the market and buy electronic devices at the beginning, then you get a book. When you open a book, you find that electronic device surrounded by the foam. الفوم يا شباب اللي هو الابيض، لونه ابيض، بيستخدم لحمايه الاجهزه الالكترونيه. لما تروح تشتري جهاز بتلاقي الجهاز ده لما تفتح الكرتونه تلاقي الجهاز ده محطوط حواليه فوم ابيض. الفوم ده being used to protect. عارفينه؟ هو ده الفوم اللي احنا بنستخدمه. هو ده so lost foam. Actually the scientific name is a poly. ايوه هو ده. انتوا بتسموه ايه؟ الفلين؟
شكله زي الفلين تقريبا.
ايوه هو الابيض ده، الابيض white in color. in electronic box you can surround the electronic device to protect. This is a foam. The scientific name called is a polystyrene. We call it foam أو فلين مظبوط. Yeah. We're going to use this foam actually. They call it also lost foam process, lost pattern process, evaporated foam process, and full mold process. Let me explain and get back to this slide again. Actually, we bring the foam. This is the foam. And there are a machine, we call it router. There are a machine. This machine cut the foam to create this is a pattern. Then we bring foam, this pattern made of foam. You bring a box, for example, a box of foam, and then put in a machine. It's like CNC machine, but only for foam. We call it router. It is CNC. Then what you need to do is to put the drawing or the design in a computer and then allow machine to cut the foam to create the pattern. So first step, you create a pattern by using a machine, router machine. This is the first step. Second step is to coating the foam with refractory material. This refractory material, the word refractory material, that is a material can withstand higher temperature. Like what here? Like aluminum oxide. We use aluminum oxide. Aluminum oxide, we bring aluminum oxide as a powder. We bring aluminum oxide as a powder and we mix with a liquid like water and then mix together and become paste like عجين يعني معجون عجين. And then you bring this one and you coat all the surface. You coat all the pattern surface with refractory material or this refractory material. So it will be totally coated with this one and you keep it in an environment for a while. It will dry. You keep it in an environment while it will be dry. Dry mean يعني تبقى يعني إلى حد ما صلبة. And then you bring this foam, the foam, and you put in a box. And then you put sand. This is ordinary sand, green sand. Then you put green sand surrounding by green sand everywhere. It's surrounded by green sand everywhere. This actually is a sparrow. This is a part we would like to produce. This is a sparrow. This is a Bison cup. This is a sparrow. This is a part we would like to produce. And then you start, no need to take pattern out. Previously, you put a pattern in a sand and we take the pattern out. Here, no need to take the pattern out. Just drop liquid on a pattern. Drop liquid, the metal liquid in a pattern. The liquid here is very hot and the evaporation temperature of this kind of foam is very low. Once you drop liquid inside, this foam will be evaporated. This foam will be evaporated. Someone will ask me how this vapor will exit here. There are a many vent. We put many vent here. Several vent. We added several vent to allow this gas to escape. To allow these gases to escape. So there are several vent here to allow these gases to escape. Okay, then when you put liquid inside, this liquid will replace the foam. Foam will be evaporated and move out. Foam will be evaporated and move out, and liquid will fill the place here. Will fill the place, replacing the foam. Then finally, you get all part here, all cavity, become cavity, all cavity filled with the liquid. Finally, you destroy the mold, you take part out. That's why we call lost foam. That's why we call lost foam, because foam will be lost, evaporated. We will not having foam anymore. Actually, let me tell you, this method or this way of casting dominating the casting in industry. يعني الطريقة دي هي الطريقة اللي بتستخدم كتير جدا في الصناعة. Why? Because the most complicated shape you can produce is by using this method. Why? Because you don't have to take the pattern out. Once you put a pattern, no need to take out. In a ordinary sand casting, you have to put a pattern and then you take the pattern out to create a cavity And for this reason, you must create cup and drag two-part and assembly, so it is really complicated. But here, no need to do actually, just simply you put the pattern inside and no need to take it out, so you can just make it is highly complicated. So the most complicated part produced by this method. That's why it is really very, very important. Yes, any question? Question? Someone would like to ask? Who? Someone
yes,
raise
I
hand.
raised my hand by mistake.
Yes, yes, by mistake, by mistake. No need to, no question, huh?
Yes, thank
Okay, so this is the most complicated casting process available and being intensively used in industry. So we call it is the lost form. We call it is the lost form or expandable polystyrene casting. Also, they call it lost form, lost pattern, evaporated form, full mold process, and this is the description as we discussed here in this one. This is the advantages and the disadvantages of this method and also application. Okay. Advantages is a pattern, no need to remove. You put the pattern, so it doesn't matter how it's complicated. Most complicated pattern being used by using lost form simplifies very easy, very simple and very easy to create the mold. We use a machine very fast and very easy way to manufacturing this one. Actually, as I told you, this advantage new pattern is needed for every cast. All expandable need pattern every cast, and also economic justification difficult for low production. This one usually higher production. It's kind of very good improvement from the sand casting application. Actually, very wide application in industry being used intensively in industry, but some application like mass production of casting, automobile engine, automated and integrated manufacturing system used for mold polystyrene and pattern and then feed from the down spiral casting. It is a explanation actually. Down spiral feed from down spiral to the cast. So it is many being used for many application in industry, automobile application, wide range being used in wide range in casting process. This is the expandable polystyrene casting. Next is the investment casting or low wax casting process. I will stop here because time is finished. Then I will